attending our webinar today. We're just going to give it a few more minutes just to let last minute registrants get signed in, and then we'll begin the presentation. All right, again, thank you everyone for attending our Thought Leader webinar today. Today's presentation is called The Heat is On, Monitoring Coral Bleaching in the Bay Islands of Honduras. Next slide. Today's presenters, we have Dr. Andrea Rivera Sosa and Kate Beebe. Dr. Andrea Rivera Sosa is a marine biologist with over a decade of experience in coral reef science and conservation in the Mesoamerican region. Dr. Rivera Sosa currently leads project management and outreach efforts for coral's conservation science programs. She also contributes to regional and global coral policy as part of the IUCN Caribbean Coral Specialist Group. Serving as a guest researcher at EcoSur Chetumal, Mexico, Dr. Rivera Sosa is focused on coral reef monitoring to support the Global Coral Reef Monitoring Network, GCRMN, Caribbean Network, and upcoming statuses and trends of coral reefs in the Caribbean. Kate Beebe is a seasoned creative professional with over a decade of marketing experience and 15 plus years in branding, design, photography. Prior to joining Coral, Kate worked with a leadership team at a global tech company. There she built the marketing department from the ground up with a heavy focus on content creation and integrated marketing campaigns. Her longtime dream of working in ocean conservation led her to using her off hours to develop pro bono marketing strategies for environmental nonprofits. As a lifelong learner, animal welfare activist, and sustainability advocate, Kate brings an ambitious spirit to Coral and is excited to spend her time and energy saving the world's coral reefs. So just a few housekeeping notes before we get started. This webinar will run for approximately 30 minutes. We'll save 10 minutes at the end to answer any questions that you may have. Simply type your questions into the questions section of the control pane, which is located to the right. Just a heads up that this webinar is being recorded, and a link to this recording will be sent in a follow-up email after the presentation. Without further ado, I'd like to introduce Kate Beebe.
Thanks, Shannon. Hello, everybody. Thank you for joining us today. I'm Kate Beebe, and I'm the Associate Director of Brand and Communications at the Coral Reef Alliance. And really, Andrea is the star of today's show, so I'll give you a brief intro to set the stage, and then I'll pass the baton to Andrea. So let's dive in. At the core, why are coral reefs important? Why do they matter? Well, for starters, coral reefs cover less than 1% of the ocean, but support a quarter of all marine life. They play a critical role in protecting coastlines, feeding communities, and supporting the economy on a local, regional, and global scale. Coral reefs are arguably one of the most biodiverse and valuable ecosystems on the planet. And while this is very simplified, let's just talk about what a coral reef is made of. There's a coral polyp, which are tiny animals, not plants, situated on a hard rocky foundation. And they're surrounded by marine life. These animals rely on coral reefs for food and shelter, and the fish and other creatures keep corals clean of algae. They recycle nutrients through their feeding and waste, and they protect the reefs by consuming pests. And they need a few essentials to survive. So the first being quite obvious, clean water, free of pollution and sedimentation. This can be wastewater contamination, sediment runoff. They also need protection from overfishing. For example, herbivores, they control algae growth and enhance coral growth. and they need balanced temperatures to avoid stress and bleaching. And that's where we come in. We're the Coral Reef Alliance. You can call us Coral. We call ourselves Coral. And we have a very passionate team of conservationists, scientists, and experts. And we're on a mission to save the world's coral reefs. I could spend an hour on just our organization alone, but since we're just doing an intro, let me just walk you through our four main strategies and how we're going to save these coral reefs around the world. So first, our team works at the local, regional, and global levels to create well-managed protected areas, to build climate resilient reef networks, focus on adaptation, reduce land-based pollution, and expand global influence. We do this by working with local partners. We never work alone. This is the Alliance in our name, and we are local first, science backed. So we also lead with science, and we target the key threats to reefs by focusing on scalable, sustainable, community-led solutions for the greatest impact. And we do all of this with an undertone of optimism and hope, because we need more of that in the world, and especially in conservation. So 2 years ago, our science team created the Coral Bleaching Toolkit and Comprehensive Guide. Feel free to scan this QR code and check it out later after the webinar. And I'm pretty sure we'll be sending you this after as well. But this resource it's a wealth of information all gathered into one place, along with actionable guidelines and resources for understanding and monitoring coral bleaching events. And Andrea was the captain of this project and did such a thorough, phenomenal job on this toolkit. And I was very new at Coral when we were building this, and my big idea was to create a dedicated month to coral bleaching to raise awareness about the issue, and also to help organize information that was kind of scattered all over the place between different organizations. So we brought it all together to help respond to bleaching, or to help people respond to bleaching events, giving them a checklist and all kinds of information in the toolkit. And just like that, Coral Bleaching Awareness Month was born. So every November this month, we bleach our logos and we remind people that life is better in color. Our aim is to educate and inspire people to spread the word about the serious threats coral reefs are consistently facing. And this is year 3. We've got influencers, partners, other organizations around the world involved. And so far, over 250 organizations have partnered in bleaching their logos across social media, on their websites, creating user-generated content, sharing educational materials, and even fundraising. So if you would like to participate this year, please visit coralbleaching.com. You can learn more. We would love to have you involved, and we can help you bleach your logo as well if you are interested. To wrap up this intro, I'm going to leave you with this last slide. So one of the most common misconceptions is that coral bleaching kills coral reefs. While it's not exactly a welcomed process, coral bleaching does not always equal the death of corals. What happens is corals expel their symbiotic algae when they're too hot and too stressed, which causes them to lose color and the ability to get food. But bleaching is reversible if conditions improve in time and the algae returns. And action now can help corals recover and survive into the future, which is our ultimate goal. The bottom line is coral reefs can adapt to climate change, but only if we help them. And that's what we are doing every day. So you kind of had a little Coral 101 and a Coral Bleaching 101. Now let's see all of this in action. How do we know to what extent corals are bleaching, which ones are bouncing back, and where? Please welcome Dr. Andrea Rivera Sosa for a deep dive into coral monitoring in the Bay Islands of Honduras. Andrea, the stage is yours.
Thank you, Kate, and thank you, Onset, for inviting us today. It's such a pleasure to be here and to talk a little bit about one of the projects in the Bay Islands of Honduras. So this is also part of a regional assessment that's usually conducted in the Mesoamerican Reef, but I'll focus on the Bay Islands of Honduras today. Thank you. Next slide. Okay, yes, thank you. So many of you heard a lot in the news about how temperatures are just increasing. And this is our new reality. We have more frequent and severe marine heat waves, and this is having an impact on coral reefs worldwide. So in 2024, the National Oceanic Atmospheric Administration and the International Coral Reef Initiative confirmed the fourth global coral bleaching event. And many of you have heard that recently the Global Tipping Report has been published and talks about how we are already surpassing this tipping point of as global warming approaches 1.5 degrees Celsius. So we are working together to try to figure out which areas are bouncing back from these events. So far, in the next slide, we'll see that studies led by Spatty et al., currently in review, which is part of the NOAA team, talk about 87% of coral reefs experiencing bleaching level heat stress since 2018. So this led to the changes in the way that NOAA creates their alerts. In the next slide, you'll see that NOAA had to increase 3 new levels of their heat stress. Next slide. And what does this mean? So before we had different color-coded heat stress levels, so no stress, watch, warning, and alert level 1 and 2 in the dark red. But because the temperatures were so high, NOAA had to increase the alert levels to alert level 3, 4, and 5. And these are presented by the different brown to purple colors towards the end. So I just want to keep in mind that these alert levels have a certain amount of degree heating weeks associated to them, and we'll talk about what degree heating weeks are as well. In the next image, I want to show you how this ongoing global coral bleaching event has been the largest to date. So here you can see how the temperature has been increasing in the Pacific during May of 2023, and how by the end of the year, this heat stress started concentrated a lot in the Caribbean as well, and in the Pacific. So you can see how the colors just keep on becoming stronger. And then in the next slide, I wanted to just quickly go over what a degree heating week is. So here you can see surface temperature graph showing the y-axis, and in the x-axis you can see the months. So here is June, July, August, September, October, and in the line we can see how the sea surface temperature increases. And so a degree heating week basically means the accumulation window of this anomaly, and this anomaly cutoff is usually when the temperature increases 1 degree Celsius. So when these anomalies in this accumulated window add up, this is what we call a degree heating week. And this is an example from Key West and Florida. Next slide. But I'll talk more also about the different monitoring techniques that are available to assess coral bleaching. We have from molecular tools to diving, temperature loggers, and even remote sensing. Today, I'll talk more about tracking coral bleaching in the Bay Islands of Honduras in the next slide, and what we did. Thank you. And the objective of the study was to create a spatiotemporal assessment of in situ data via loggers, and also satellite temperature data from NOAA to assess coral bleaching in the Bay Islands, Honduras during 2021 to 2023. So what we did, the methodology included setting up loggers at 38 out of 40 sites because we ended up losing two loggers that we couldn't find. But we installed these tidbits onto the reef in areas that were dead reef, and then included a small buoy so that we could find them afterwards by georeferencing them as well. They were in the water from 2021 to 2024, and we included them in areas that were adjacent to existing monitoring sites. And I'll talk about the methodologies that we use. So in the next slide, you'll see that we use the AGRA methodology. Some of you have heard of this. This is a standardized methodology used in the Caribbean. It's the Atlantic and Gulf Rapid Reef Assessment. And basically, you set up a line, a transect that's 10 meters long, and colonies are assessed at the species size and health. And here we assess if they were normal or bleached and the percent of the mortality. This is a method that is usually applied for reef health studies. And the next slide shows the bar drop methodology. This is roving diver method. So we use a 1 meter PVC stick that is marked at every 10 centimeters, and we assess 200 colonies per site. We usually look at if the coral is healthy, if it's normal or bleached, and also calculate the percent mortality. And this method is applied specifically for coral bleaching monitoring programs in the Mesoamerican reef. So this is a map of the Mesoamerican reef located in Central America, and we can see a box showing the Bay Islands of Honduras, beautiful diving destinations. And here are the sites that we installed in Utila and also in Roatan, shown in red. And then the next slide shows the sites that we use for monitoring coral bleaching. So to talk about some of the results, here you can see the two different graphs. So this is for the temperature loggers in Utila. Something important to keep in mind is that the blue diamond represents data for 2021, 2022, and these are the non-bleaching years. And then in red, the diamond in red shows only 2023, which was the bleaching year. And apologies if you hear lots of rain, lots of noise. It's raining here in Bacalar, so you'll hear some of the noise in the background. But here it shows the in blue also the area or the months that are resemblant to the rainy season. So mid-September to mid-January is usually the rainy season, and then in dry you can see in yellow. So basically the results show here how temperature is increasing in red 2023, and how when it starts the rainy season, the temperature starts dropping down. And Utila was one of the sites that had the most variability in temperature, mostly because some of the sites were really shallow in enclosed areas. So next slide is the temperature for Roatan, which also has the same pattern with less variability here in the temperature ranges. Something important to highlight is that during the 2023, we had temperatures that were over 1 degree Celsius for these sites. So this meant that the temperature was really high for these areas. And then in the next slide, we also wanted to look at the historical satellite temperature. So this is from NOAA and the Coral Reef Watch data. And interestingly, comparing the 2023 and 2024 years, we see that the duration of degree heating weeks were much higher in these 2 years. And in the next graph, you'll see also that 2023 and 2024, we had a high peak of degree heating weeks for each event. And then in the next graph, we'll see that the onset month was earlier. So here it's represented by the months, and we can see that from 1995 to 2020, the months were usually around October and September when it started to get warm. But for 2023 and 2024, this occurred in June, which is much earlier than compared to the past 28 years. So in the next slide, we can see some of the results. And apologies because I didn't include any of the pictures showing the different bleach corals, but this is a map showing the bleaching severity. So the ones that are in white have very low bleaching, and then the ones in red have higher bleaching percentages by this index. So what we saw is that sites in the north were less bleached than sites in the south. These surveys were conducted in September and October, and I will soon explain a little bit of why we found that as well. And in the next slide, here are some of the results for the bar drop method. So the first ones were the AGRA results, and then these are the bar drop. And since these surveys were conducted in the peak of the bleaching in November to January, we see that that these colors are red, indicating higher bleaching. So in the next slide, I want to show how the degree heating weeks have changed over time. So these last two peaks represent 2023 and 2024. So you can see that the satellite data is also indicating us that this temperature started increasing earlier than the last years historically. And then in the next slide, you can see the degree heating weeks from 0 to 15. Here we're very close in the peak. And in the bubbles representing the results of the survey. So in blue, we can see that bleaching was low in September. Then the next bunch of surveys that were conducted in between start showing some of this increases in bleaching severity index. And then the next surveys that were conducted were also during this gradual peak that was going down. And then some of the surveys that were conducted in January when we didn't have a peak of the degree heating weeks. So next slide. I like to highlight why we saw this difference of the north and south. So in the north, we had less degree heating weeks. I mean, less bleaching severity, sorry. And here I just want to point out, starting from the south, how we found the temperature. So here in this graph, the top one, you can see two lines. One that is in blue, slightly, you can see it. This is the degree heating weeks from the Coral Reef Watch. And then you can see the degree heating weeks in black from the in situ data, from the loggers. And here you see some threshold lines indicating the different levels that we saw in the beginning of the degree heating weeks. So what we found is that we were up to 14 to 15 degree heating weeks, but the surveys in the south were done in October. So this is right where the peak was increasing. And then the surveys in the north were done before. So these were done in September. And that's why we get this this difference in the results of bleaching. So some key findings to start wrapping up is we found that it's important to have a maintenance process within these tidbits. It's also important to make sure that you have a good metadata in the sense of when those tidbits went in, when they were deployed, to make sure that those data sets are cleaned out, so that you can also remove anomalies. We found that the cell phone and the Bluetooth process was easier on the boats because we didn't have to do the process twice when we have the other type of temperature loggers, but the batteries are not replaceable in this type of tidbit. What we did see is that it lasted more than 3 years in the water, and we still have tidbits that have good batteries. And something important with calculating the degree heating weeks of in situ data is that it's important to take into consideration that when this is calculated, that you only take nighttime temperatures, because when we compare it with the degree heating weeks from the satellites, these are only taken in the night. And so when we have the range of temperature throughout the day, then we have higher temperature. And some of the key findings of the study in the next slide is that we found that this thermal stress began accumulating earlier in June, as mentioned before, occurring earlier than in the past 28 years. We also saw that the temperature remained elevated through 2024, also leading to significant bleaching. And what we saw with the north and south differences, for example, in Roatan, show us that the timing of monitoring is crucial. So just 2 to 3 weeks can result in major differences in observed bleaching severity. So it's important to keep that in mind. And this work was coordinated by a really large group of people. So this is also important to highlight that this coordination about multiple stakeholders in the region and in the country is important for the program. And with that, I would like to thank all the different organizations that supported this work. This was also led, all the research and data analysis was led by Rebecca Green. So thank you so much. And a large team of different local partners, Healthy Reefs, UNAM in Mexico, the Roatan Marine Park, Bicautila, and AGRA. So thank you again for listening. I'm happy to take any questions, and thank you again, LICOR and HOBO, for inviting us to this webinar series. Thank you.
Thank you so much, Doctor. We did have a question come up. Aside from temperature, what other parameters can contribute to coral bleaching?
when we talk about massive coral bleaching, temperature is usually the main precursor of that. But if you're interested in looking at other parameters, I think water quality is also important, because it can also be a stressor to corals. But temperature is usually the main parameter measured. Something that's interesting and I didn't talk about is also the species response. So if we look at temperature as the main precursor and then also look at the different responses, we can also see that some corals are affected more than others, and some are more resilient in this sense. So that's something to keep in mind.
Excellent. And we actually have a two-part question here from Dennis. The first part was, do you log one data point per day, or do you monitor around the clock, say every 1 to 4 hours, but only compared to satellite data using nighttime data? And then the second part of that was, what depths do you mostly measure in?
Okay, great question. So we focused on an average depth of about 6 meters for this study. And the other question was about the loggers. So we had them set to measure at every, I believe, 10 minutes. So you can even do it every, you have many options, but the more detailed you go, the less battery life you will have. So we had them set out at every 10 minutes approximately, and then we did averages throughout the locations, and that way we had the temperature range.
Great, thank you. We do have a question from Jessica, and she was inquiring if you have plans to track water quality at the reef sites.
That's a great question. There is a water quality program in place, led by the different local partners. So BICA, also Roatan Marine Park in the Bay Islands of Honduras. But these sites are not located all over. So there's they're not all the same as the studies that we had, the bleaching, but some of them aren't. So there's like a subset of sites that have this information. So yes, and there's also a regional water quality protocol that you can also check at the Coral website that incorporates what are those parameters that can be measured how throughout the region.
Thank you for that. Zos has a question, and he was asking, what are the actions with scalable impact that can be taken in order to regenerate and conserve coral reefs, apart from research?
Wow, that's a really good one. So what are can you repeat it again?
Absolutely. What are the actions with scalable impact that can be taken in order to regenerate and conserve coral reefs apart from research?
Apart from research. Yeah, so this is more of a policy question. So I think that one of the main recommendations is that we need to slow down and curb our emissions, our greenhouse emissions, because if we don't do that, then we're still following this tipping point trajectory. So it's important that we do that as governments and as nations and at the global scale. I think the second action that we can do that is also very important is to ensure that we have clean water. And this is not just clean water for drinking, but also clean water that goes into the ocean. So we have major gaps in our wastewater treatment. And this is global. This is a global issue. So we really need to work towards that. There's different conventions that set guidelines on how we need to reduce the nutrient contaminants going into the water, because if we have waters with a lot of nutrients, then we have more algae, and it's a really a big competitor with corals. So we're making it harder for corals to rebound when they are these marine heat waves. And then the other one is also working with different types of marine protected areas. Some are managed locally, some are more national, but I think that also helps give corals a chance with more regulations and fishing regulations and such. So I would say that those would be some of the main ones, the main actions that we can do.
Excellent. Thank you for that. And Brian did come in with a few questions here that are referring to coral reefs. And he had mentioned, what about the role of light level in thermally induced photo bleaching?
That is a really good question. So usually bleaching is not a two-way linear relationship. We have many other factors that influence coral bleaching. One of them is light, as you mentioned. So some of the corals that may be exposed to more light, for example, that are located in the reef crust or in shallow areas, can have more of an impact from light. Here we focus from 6 to 7 meters. What we also found and we're not sure if it's really in relation to light or if it's more of a sensitivity issue, is that we found that corals, and this is from another study, the corals that are located in deeper waters tend to be more sensitive to bleaching. And what else? Yeah, something else to consider is that corals can have the capacity to change their zooxanthellae. So there's different associations of these zooxanthellae called clades, and depending on which clade the coral has, it can be more thermotolerant. So there's the clade D that has more thermotolerant zooxanthellae, and then what we're seeing is that these are the corals that are surviving a little better when there are these marine heat waves. So it's important to know what clades they have, but that also means that there's needs to be more detailed molecular research, which we didn't do in this project, but we did do genetic studies for two species.
Okay, then he also asked, and I apologize if I mispronounce these words, are all the clades, C-L-A-D-E-S, Symbidium? I think it's how you say that. I apologize if I mispronounce that. Symbiodium.
Here, let me see if I can see it in the in the chat. So are all, the question is if they're all the clades are symbiodinium. Is that the question?
Yes, thank you.
Great. No, they're not. They are different. And I have a resource that talks about the different ones, but they're not. They are different. So I think it's, I don't want to say it because I'm not 100% sure, but it's only one of the clades that's symbiodinium, and then the rest of the clades are different genera.
Perfect. So you did follow up and say so several species. Thanks. And we did have another question come in that I think is more of a global question for the group here. And they're asking, does Hobo facilitate any global database that we can contribute with data recorded? I can answer the first part and then I will let you jump in after that, Doctor. Here at Hobo, we supply the tools to be able to collect this data. I wouldn't consider us a resource for data that's collected. That's when I would refer to organizations such as Coral. This is an ongoing study, so I'm assuming they are putting a database together, and maybe it will be opened to the public to be able to contribute as well, but I will let Dr. maybe fill in some additional gaps on that.
Thank you. So there's a platform called Aqualink, and Aqualink has a set of different buoys all over the world. Some of them are physical buoys that collect data on temperature, waves, and also wind direction. But there are other ones that are virtual buoys that you can create for certain sites. Once you create a site, you can upload data from your temperature loggers. So I think this could be a good site where data can be available at the world scale. And then each person can upload, and then different people would be able to download that information. But that's something that's still being sort of being developed and outreached. I don't know of a set global database for temperature loggers yet, but I think that could be a good start.
Great, thank you so much for sharing that information. I think that does take us to the end of the presentation. We have gone a few minutes over, so I want to thank all of our attendees for sticking around while we address some of these questions. I do want to give a huge thank you to both Dr. Andrea and Kate for taking time out of their day to share this information with us, share some best practices for the type of monitoring that they're doing, and then also helping save our oceans and making sure that they're sustainable for future generations. So again, thank you so much for your time today. We truly appreciate it, and I hope everyone got something out of this presentation today. Thank you.
Thank you. Lots of great questions.